Stepped up the complexity of this question because I reckon we could probably do it. So what we want to do is we want to fully factorize this fourth order polynomial, given that we know it has a factor of, or given that we know x plus 3 all squared is 0. Now if you look at this one's slightly different from the last example because there are unknowns in the expression here itself, so the polynomial expression. And the 0 is not a linear factor, it's a quadratic factor. So, how do you think we go about doing this? What was our first step in the last one we did?
Build algebraic expression.
Build an algebraic factorized expression. So if we were going to do this, we know that this guy over here is going to be equivalent to, firstly it's x plus 3 all squared is going to be one of the factors. And then inside, we have to think we're going to have unknown a, b, c, but you can already see a and b are taken. Are there any other variables we could use?
Probably like x.
X.
Big X.
Literally could be anything.
Yeah, so I like to go with the Greek alphabet when I've already used up letters here. So I'm going to start off by going alpha x squared plus beta x plus gamma. Now we can do a little bit better with this because we need to think about it. Have a look at the values we know here and here. If we look at the coefficient on the fourth order term, it's 3. Now if we look at this expression here, if we expanded this out, what would our coefficient on the fourth order term be?
3.
It's going to be 3 as well, but what's in representation? If we expand this out, it's x times alpha x squared. So what we can see by inspection without actually doing anything is we know that alpha is going to be 3. What about beta? Can we determine that straight out of the gates?
No.
No. Gamma?
Yeah, probably. No.
Gamma?
No. Yeah, you can.
Think about it. The linear term is always going to be the multiplication of all the constants together. So it's going to be 3 times this. But the problem is, this is a squared. So it's going to be 3 squared
Times gamma.
gamma equals minus 45. Does that make sense?
Yep.
So we know that gamma is going to give us negative 9. Negative 5. Does that make sense how I did that straight out of the gates?
Yep.
So whenever you're dealing with unknowns in the highest order and the linear, most of the time you can pull it straight out of the original expression just by inspection. Next, simply build what we have. We have x plus 3 all squared. It's going to be 3x squared plus beta x plus, or it should be minus 5. Okay, so here's our expression. 1 unknown, 2 unknowns. Next step, what did we do last question to be able to discover all of our coefficients? We had to factorize, what did we do to it?
So how did you get the negative 45 in the 3 squared?
Okay, think about it. The linear term is what?
Oh, negative 45.
Negative 45. If we look at the factorized form, the linear term has to come from 3 times 3, or 3 squared, multiplied by gamma, because that's a linear factorized term there.
Yeah.
Make sense?
Yeah, that makes sense.
Yeah. So whenever you can do something by inspection, do it. It will make your life easier. Next step, we need to expand. The way we expand this is we use our favorite form of multiplication. We're going to grab our -5, we're going to grab our beta, we're going to grab our 3. And when I first did this question, I was very silly and I didn't look closely. And I said 1 and 3. What is the error in my way, Lenny?
You forgot to square.
Yeah, I forgot to square it. This is a squared term. Because of that, I wouldn't get fully expanded. So what I need to do is I need to expand this out. I know that this is a perfect square, so this is going to be 1 plus 2x plus 9. Are we all cool with that? So this down here is my squared. This up here is going to be my quadratic. I then multiply. Yeah, just checking. Okay, expanding this out. -45, 9 beta, 27. Shift, -30. 6 beta, and then 24. Double shift. This is going to be -5 beta, and then 3.
Yeah, it's 18, not 24.
Oh, so it is.
What are we looking into?
Making a lot of mistakes today. Or am I just keeping you guys on your toes?
Nothing, just that one on the
No, I just make a lot of mistakes. Alright, so we sum them all. -45. This is going to be 9 beta minus 30. This is going to be 6 beta. And then 27 take 5 is going to be 22. This is going to be beta plus 24. And this is going to be 3. Boom shakalaka. All of a sudden we have our coefficients. This is x to the 0, x to the 1, x to the 2, x to the 3, and x to the 4. So, writing this out with what we have, our expression 3x to the 4 plus ax cubed plus bx squared minus 12x minus 45 is equal to, it's going to be, where are we, 3x to the 4, that's what we knew, beta plus 24, plus 6 beta plus 22, plus 9 beta, take 30, minus 45. And again, it's a matter of doing inspection here. So we have ax cubed, beta plus 24x cubed, bx squared, 6 beta plus 22, and then the final one, negative 12, and so on. How many unknowns do we have here? 3. How many equations could we build? 3 different equations. Now this is one of the steps where you have to have a look at what you have and take the easiest path possible, so the path of least resistance. Most of our equations we build are going to have more than one unknown. Are there any equations we can build that only have a singular unknown?
Yeah.
Which one would it be, Brad?
The 9 beta x.
Yeah, the ones with the blue underlining. We should always try and pick the one that has the least amount of unknowns because it's easier to solve. So first equation we can build up is going to be 9 beta, whoops, take 30 equals negative 12. Solving this, add 30 to both sides. This is going to give us 18. Divide by 9, beta equals 2. Alright, do we need to go any further? Or could we factorize this from here? Remember, the question's asking us to fully factorize. Do we need to find any unknowns, or can we factorize from here? Hands up if you want to factorize, or sorry, hands up if you want to find all the unknowns. Hands up if you want to just factorize from here. Hands up if you probably should just factorize from here. Yeah, I do want to find all the unknowns, but we'll do that after. I'll show you a trick on the calculator. Okay, what we're going to do is we're going to fully factorize. Remember, that's what the question wants. Factorize. To fully factorize, we've already got this form over here. We know the value of beta. So, we're going to get 3x squared plus 2x, take 5. Now, we've got 3 different things we could do here. Or 2 actually. Oh, yes.
0, x to the 6.
Have I made a mistake?
I'm just wondering.
Where?
With the negative 45.
Yes?
Is it x to the 0?
Yeah.
Yeah, x to the 0, sorry.
Does that be x to 6?
Oh no, I was confused.
It did look like a poorly formed 6. Sorry, 0. It's a poorly formed 0, but now it's even less poorly formed. Okay, can we factorize this?
Yeah.
What method do we use? 3 times minus 5 is going to give us negative 15. What 2 numbers, oh sorry, it's negative 15. What 2 numbers multiply to give negative 15 but sum to give 2?
3 and 4.
Yeah, oh, why did I do that? Oh yeah, because it's 3 and 5. Yeah, that's so smart. Okay, so we're going to get, in the bracket here, it's going to be 3x squared plus, this one should be negative 3. This should be 5. This should be 5, of course. And then we can simply just factorize this on 2 more lines. This will be 3x, comes out. X take 1 gets left behind, plus 5x take 1. Finishing this off, or finish it. Done. There's our factorized form. So the method for this, guys, is build an algebraic expression. You'll be doing this constantly throughout this topic. Build an algebraic expression, expand out your algebraic expression, use inspection to build equations, solve the equations that are actually relevant, so you don't need to find every single unknown for every equation you can build, and then finally finish the question. It could be fully factorized, it could be determine the polynomial itself. If it was determine the polynomial itself, then what we'd end up doing is finding A and B as well. All cool?
Yep.
All right.